The question of whether the universe requires a creator or a god has been a topic of debate for centuries. However, in recent years, advancements in our understanding of quantum mechanics have provided a plausible explanation for how the universe could have emerged by itself from a state of quantum fluctuation, without the need for a god or a creator. To understand this argument, it is essential to first understand what quantum fluctuations are. In the quantum world, particles do not behave in the same way as they do in the classical world. Instead, they exist in a state of constant fluctuation, where they can appear and disappear at random. These fluctuations are a fundamental property of the quantum world and are well documented by experimental observations. Now imagine that the universe exists in a state of quantum fluctuation. In this scenario, the universe would be a quantum system that exists in a state of constant flux, where particles appear and disappear at random. Over time, these fluctuations could lead to the emergence of a stable universe, with matter and energy arranged in a particular way. Quantum fluctuations produce virtual particle pairs, which will annihilate each other in a short time. However, when a quantum vacuum bubble appears, these virtual particle pairs will be separated from each other, thus producing real particles, one of which will be trapped inside the bubble and evolve with it, forming the structures of matter and galaxies in the formed universe. In 2014, Dongshin He, Dingfeng Gao, and King Yu Kai from the Wuhan Institute of Physics and Mathematics published their paper titled Spontaneous Creation of the Universe from Nothing, using the Wheeler-DeWitt equation as its foundation. Through this paper, they provided mathematical proof that the universe can emerge spontaneously due to quantum fluctuations. Dongshin and colleagues' publication explored solutions to the Wheeler-DeWitt equation under the conditions of quantum vacuum bubbles, which support the hypothesis of the spontaneous creation of the universe. According to the Heisenberg uncertainty principle, Planck-sized vacuum space bubbles can probabilistically emerge from nothingness due to fluctuations at the quantum level. This condition is known by physicists as a metastable false vacuum. If this condition occurs, there are two possibilities that will happen afterwards. The space bubble will immediately disappear, or, under certain conditions, the bubble can expand so greatly as to create a universe, and this process cannot be reversed. Dongshin He and his colleagues successfully provided a strong mathematical foundation that the origin of the universe was due to quantum fluctuations. So, the universe can emerge from the chaos of quantum fluctuations, not from nothingness. Quantum fluctuations are always there and will always be there. Therefore, the phrase nothingness is actually a phrase used by humans to describe the condition of the absence of matter, because our five senses cannot observe and experience quantum fluctuations that are so small and continuous.